Hello everyone, welcome to the July Recreational Astronomy Night meeting of the RASC Toronto Centre, online version. My name is Paul Markov and I will be your virtual host for this evening. I hope you had a chance to see Comet Neowise. If not, you definitely still have time in the days to come. Please make the effort, it's definitely worth it. Before we start the meeting, I'd like to thank in advance our technical team, comprised of Andrew and Betty Reed, Blake Nancaro, Ward Legros, and Enya Chulucci. Thank you all for making these online presentations possible. We have 4 speakers for this evening, rather than the usual 3. However, I expect we will still be done by about 9:30. So we can go out and see the comet if it's clear. The speakers for tonight are Chris Vaughan, presenting the sky this month. We have David Robitaille. He'll be talking to us about imaging from his backyard. Artash Nath will be next. His topic is From Outer Space to Subsurface, the role of seismic vibrations, how to measure them, and the impact of COVID-19. And finally, Frank Dempsey will wrap up the evening and talk to us about his progress on a 12.5-inch mirror grinding and telescope making project. And finally, to close the meeting, President Ralph Chou will do the usual announcements. And that'll be that. Hopefully, it won't be later than 9:30. Now, some housekeeping items. If you have any questions for our speakers, you can ask them through the YouTube chat window. And Blake Nancaro is going to ask the questions on your behalf to the speaker. And also, if you're attending our meetings online for the first time, whether you're a member or not, please drop a message on the chat box so that we know you're there. So I think we're good to go. Let's get started with Chris Vaughan and the sky this month.
We're good? Good evening, everybody. I'm going to do a sky this month spritzer edition, a fun and frothy summer edition, a little bit lighter than our normal detailed deep dive. So I'm covering the month from tonight through August 19th. More or less. And I'm going to kick off in a minute here with a look at the comet, what it's up to. But first, I just want to mention a couple of space exploration things to be on the lookout for. First up is that the Emirates are launching a mission to Mars. That launch is scheduled for tomorrow at 4:43 p.m. Eastern Time out of Japan. And then on July 30th, NASA expects to launch their Mars Perseverance rover. That's the Mars, formerly known as the Mars 2020 rover. It's about the same size and shape as the Curiosity rover on Mars, the nuclear-powered rover, but this one is going to be more of a robot biologist, and it's more a mission to search for signs of life or past, present life on Mars. And that's, as I said, July 30th. The window for that one opens about 7:50 a.m., so you may want to keep your eye on the news about that one. So this time of the year, we're still dealing with fairly short nights, but the sun is setting a little bit earlier every day now. We're actually gaining about 1.5 minutes of night darkness every day at this point in the year. And astronomical twilight is the phenomenon when the sun is lower than 18 degrees below the horizon, and we consider the sky to be fully dark at that point. And right about now, astronomical twilight ends and the sky gets its maximum darkness at about 11 o'clock. And then it starts getting light again around 3:30 and 3:40 in the morning. So that gives us about 4 hours and 40 minutes if you're an imager and you want a nice black dark sky without the moon gone from the picture. By our next meeting on August 19th, astronomical twilight will end earlier at 10 o'clock and resume at 4:40. So we've actually gained 2 hours of dark sky in the next month. So that's pretty exciting. All right, so I'm going to use stellarium here to give a sense of what's up with Comet Neowise. So I highly recommend, if you want to see the comet, you need to find a location with a nice low and open northwestern horizon in the evening, or a low and open northeastern horizon in the pre-dawn. I'm going to focus for the moment on the evening sky. So we've been out to look at the comet, a number of us, and we could pick it up in binoculars starting around 9:45. The sky is starting to get dark enough to reveal it. And by 10 o'clock, it's becoming a naked eye object. So here's the area of sky we're talking about. I'm just going to advance the time in stellarium here to about 9:45 or so. So you can see Comet Neowise here. It's actually sitting in the sky, almost directly below the Big Dipper. It's actually moving in a northeasterly direction, so that northern component of that motion is making it become a circumpolar object, which means that over the next number of days, it will actually not set at all, but it will skim the northern horizon in the middle of the night and then come up before the dawn again. So this is the sky shown for the Toronto area. And if I advance the time from 9:50 p.m., 10:50, and by 11:50, by midnight, it's obviously far too low to observe. But by the time we get to about almost 4 a.m., we're getting to a point where it's rising above the horizon in the northeast. And you've got, in the morning, I think you've got a shorter window of time to see it before the sky begins to get bright again, and you lose it. So I highly recommend the evening approach. So let's go back to the evening sky here. So if I set this to 10 o'clock, at 10 o'clock, the height of the comet above the horizon is about 13 degrees. So that would be equivalent to maybe a larger fist than I am, but roughly a bit more than a fist's width, held at arm's length with one eye shut and the bottom of your fist on the horizon. So it's quite low. And of course, it's descending and dropping towards the north. You know, we're used to things dropping towards the west, but because it's circumpolar, it's heading the other way. So if you get out there later, you want to be looking more to the right than to the left of what I'm showing here now. Now, the constellation Lynx is not a particularly easy tool to help navigate you because it doesn't have a lot of bright stars in it. But the two bottom stars of the Big Dipper will be a great help. So in tonight's sky, the comet is nearly directly below Dubhe, the star Dubhe in the bottom of the Big Dipper. And if I show you what it's going to do over the next number of days, you can get a sense of what to expect night by night. So roughly it's going to ascend about a thumb's width in the sky every night and continuously slide off to the left here. You can see it's getting higher and closer to the Big Dipper. If you go back to on the 18th of July, if you could pick up the little toe stars of Ursa Major, it'll be flying very close to them. And then a few days after that, it's going to be sort of in the vicinity of the rear foot of Ursa Major. And this night of July 23rd is about the night when we expect the comet's orbit will carry it closest to the Earth. And that will mean the comet is larger in the sky, but it also means the comet is farther from the sun and is receiving less heating from the sun, and therefore it's fading in brightness. So at the moment, the comet is already descending in brightness, and eventually it'll sort of drop below the threshold where it's naked eye, and then as it heads into the sort of later summer sky, we'll probably end up chasing it in our telescopes and things like that as it sort of heads up into Coma Berenices area by the end of July and on from there. But that'll give you a sense of where to find it this week. And obviously, the sooner you can get out and look at it, the better, because it's still nearer to the sun and still a bit brighter. And we never know if the comet's going to fizzle out and break up, and the show will be over. So do get out, make an effort to get out and take a look at it. All right, so let me just get on to some other regularly scheduled astronomical events. So the other big news that would normally be taking center stage in this week of the month would be the fact that we've reached the point where Jupiter is at opposition. You can see Jupiter is here in the southeastern sky about 10 p.m. And at opposition, let me just bring up my trusty opposition diagram here. So all the planets circle orbit the sun, in the same sense, and Earth being closer to the sun is on the inside track. And that means that once a year, Earth passes Jupiter and the other planets on the inside track of the orbits. And that means that on that day of the year that the Earth's distance from that planet is at its minimum. And that will cause that planet to appear brighter. It'll cause it to appear larger in telescopes. And if it has moons that we're interested in tracking down, the moons themselves will be a little bit bigger and brighter. So it's really the optimum time to chase down and look at the planets. But the thing to bear in mind is that at opposition, both the Earth and the planet, Jupiter or Saturn, whatever, are both traveling parallel to each other. So it's really not necessary for you to get out there and look at it on the night of opposition. It's really just as good for a number of nights on either side, you know, perhaps for even for a week or two. It's going to be practically the same size and brightness in the sky. The other thing that happens at opposition is that the planet is opposite the sun in the sky. So as the sun sets, that planet rises, and that means it's visible all night long. So you have all evening to have a look at it. Now, it turns out that we have a bit of a traffic jam of planets happening right now, and that we have Jupiter, we have Pluto, and we have Saturn all within about 6 degrees of each other. So Jupiter was at opposition last night. I believe Pluto was opposition is tonight. And again, Pluto being such a dim 14th magnitude target is a bit beyond the reach of most amateur telescopes. But if you're going to see it, this is the week to see it when we're at its closest and brightest, as meager as that might be. And then on Monday, Saturn has its turn to reach opposition. We also have an asteroid Pallas, which should be in the neighborhood as well. Let's see if I can pick up Pallas. Not sure where that is right now, but if you're interested in looking at an asteroid, you can sort of look for that in your planetarium software and check that out. All right, that's next. Now, the other great thing that's happening because of Jupiter as being at opposition is that its alignment, the alignment of its moons towards us and the sun are more face on, which means that we get a nice little set of shadow transits across the face of the disk of Jupiter. And in fact, we even get some double shadow transit events. So let's see if I can pull one up here. On the 17th, let's see, it's on the 16th around this time. So, oops, let's go back here. So here's the first cool one. This is on the night of the 17th. That's Friday night. We have the black shadow of Europa transiting across the northern part of Jupiter, accompanied by the Great Red Spot. So they'll go for a while, and then yeah, that's that one. So let's just sort of march through the month here. So that's this week. Let's talk about the moon for a second. So we'll sort of do this chronologically through the month. So we'll find the moon. So what we also have is the moon visiting Venus. That's happening on Friday as well. And this would be an opportunity, in fact, to probably be able to see Venus in the daytime. So this is the pre-dawn sky in the east around 4:20 or 4 in the morning. As we get after sunrise, you can see that the moon and Venus will cross the sky together. The distance between them is about, let's measure this up here. Need my glasses to read it. 4 degrees, 4 degrees, that's about 4 finger widths. So that would be, put them both within the field of view of binoculars. So in theory, you could later in the morning, train your binoculars, being very careful to avoid the sun, of course, on the moon, and look for Venus's bright little speck of light down to the lower right of it. Now, a day or two later, the moon will hop down and sort of join Mercury. Mercury is not that favorably visible in the morning right now, but if you get up kind of 5:30-ish in the morning and look to the east, you might be able to find the crescent moon first and then look about a palm's width to the right of it to find the little bright dot of Mercury in the sky. Mercury is actually going to reach its greatest elongation on the 22nd of July. So that'll be its greatest distance or greatest angle away from the sun. And that would be its sort of maximum visibility. You can see that Mercury will be best viewed probably in the period just after 5 a.m. if you want to see Mercury around that time. Then on the 24th, we have another shadow transit on Jupiter, again accompanied by the Great Red Spot. On the 27th, we have the first quarter moon. And then on the 28th of July, we pick up the Southern Delta Aquarids meteor shower. That meteor shower is a modest one. It's 15 to 20 meters per hour. That one's going to have a waxing gibbous moon on the peak. So let's find the moon again here. Just sort of show you what the moon will look like around that time. All right, so we'll get into around the 28th. So that's a pretty bright moon that'll be sharing the sky for that particular meteor shower. But that's okay. Stay tuned. We've got better news coming. All right, that's the end of July. Let's switch over to August. All right. So on August 1st, let's keep the moon in the view here and pop through a couple of nights. So on just before midnight, let's switch off just before midnight. So it's just before midnight on the 1st of August, we've got that monthly visit of the moon with the gas giant planets, Jupiter and Saturn. So they'll make a pretty sight, maybe a nice photo op in early evening. And then if you want to, you could also try again sort of around 3 in the morning to get them in the southwest. So they'll make a nice view that night. That's a great one. The full moon will happen on the 3rd. Obviously the moon rises, the full moon rises as the sun sets. So that's sort of giving us our poor sky conditions for deep sky observing. But as my friend Blake Nancaro likes to mention, there are always double stars. You can head out and chase down some double stars. All right. Next night or two later, so let's just advance a few more nights here. The moon is going to visit quite close to Mars. And they'll linger into the daytime sky. So that might be another opportunity to point your telescope at the moon and then slew over and pick up Mars in the daytime. I've done that before. It's really quite cool. Again, be sure to be avoiding the sun at all times when you're using the telescope or binoculars in the daytime. A few days after that, we get into the August 11th, 12th period. And this is when we're getting the period of the peak of the Perseid meteor shower. So the Perseid meteor shower is one of our favorite showers of the year, often produces bright fireballs, persistent trails that leave a train of smoke that dissipates in the sky for a minute or two after they leave. The shower starts on the 17th of July and runs till about the 26th of August. But of course it ramps up at a peak on the night of August 11-12. And the source of the meteors is up here in the constellation of Perseus. And the meteors will appear to be radiating in a direction away from the constellation Perseus. Now, unfortunately, the last quarter moon is going to be sharing the sky in the pre-dawn. Now, normally we suggest looking for meteors in the pre-dawn because at that time of the day, or that time of the night, the Earth, the sky above you is the part of the Earth that's plowing directly into the field of debris that's producing the meteors. But because we've got the moon in the morning sky, what we recommend, at least for this year, is just start looking in the evening. So starting after dusk on Tuesday night, the 11th, you can start looking for Perseid meteors shooting across the sky all night long. Definitely worth going for. I did note that next year, the Perseids will land on a new moon weekend. So that'll be a great angle for us. A couple more things to cover before the reporting period is over. On the 13th of August, we've got Venus reaching its greatest elongation from the sun. in the eastern morning sky. Venus will reach a magnitude of -4.43. It'll be the brightest thing around at that time. On the 14th of August, we've got another transit of a Ganymede shadow across Jupiter with the great red spot accompanying that. That's going to be happening around 10:30 p.m. That's an excellent, convenient time to catch that. And then on the 15th of August, let me just bring us up to the 15th. Grab Jupiter here. Let's see if we can pick this up around. There is a double shadow event. This one is happening on the 15th. Let's go back. There we go. So there we have a triple play here. We have both Ganymede larger shadow, we have Io smaller shadow, and the great red spot, all visible just after midnight. So this is on the night of the 14th, but it's after midnight. It's now the 15th. So let me just reinforce that. So the event starts on Friday the 14th and then continues into the post-midnight period on the 15th. So you want to catch that. And finally, we get the new moon occurring on the night of August 19th. So basically, our great dark sky observing periods would be from now until July 22nd, which is about 2 nights after the new moon. And then again on August 11th to the 21st, which is about 2 nights after the new moon. ISS flyovers. If you're interested in seeing the space station, right now we're entering a period where we're getting a lot of nighttime passes. And what we often recommend people do is navigate over to the website heavensabove.com. You need to make sure that you type in your location in the location window here. Once you've done that, then you can search from a variety of options, and usually if you click on the ISS choice, then it will list all the passes of the space station over your location on the given date, how bright it will be, and of course, the more negative the number, the brighter the pass will be. It gives you the start time, the highest point time, and the end time of the pass. Let's see if we can pick up a bright evening pass here. Here's a good one on the 24th of July. If you click on the date, it'll bring up a map of the pass. It's only going to be hitting part of the sky until it disappears into the Earth's shadow, but it'll be very, very bright, starting at about 11:40 p.m. So that sort of gives you a sense of how to use heavensabove.com. If you advance the right arrow, it gives you the following week. And then the week after that, we run into the end of the period. So the ISS flyovers come in sort of cycles or waves. And this series of evening visibility passes will end on August 4th. And then there's a big gap, and then they'll come back in the morning sky after that. In terms of what you might want to look at during these dark sky periods, let's just come back to tonight, aside from comets, that is. So you can use Jupiter. I can recommend that if you navigate over to the RASC Canada YouTube channel, Jenna Hines and I did a tour of the summertime Milky Way video there yesterday, and highlighted a number of targets that you might want to look at in the summer Milky Way sky, summer southern sky. So in Stellarium here, you can bring up symbols and labels for all the various deep sky objects that are available in the night sky. If you don't have a big telescope or you're just a beginner, one of the things we recommend you doing is just get out with your eyes, or if you have binoculars, and start exploring the Milky Way. The way you can find it is look for the bright star Antares, which is the heart of the Scorpion. And you can find the 3 little dots, 3 little stars forming the Scorpion's claws, just to the upper right of that. And then follow the tail down and around to this nice double star named Shaula, and that's coming down. The best time to look at objects is when they're highest in the sky, and when they're highest in the sky is when they're over the southern horizon. If I put up a mark here for the meridian, so you can see that if you can get the objects to be sort of crossing this line, then they'll be viewed at their best. And so the Scorpion constellation Scorpius is crossing the meridian right now at around 10:15 p.m. So if you find Antares and put your binoculars on it, you can look just a little bit to its right and pick up a nice bright globular cluster. Get rid of the symbols for a second. That's Messier 4. So that's an easy, very easy one to find. If you head over a little bit to the east here, you can pick up this distinctive asterism of the teapot. It's the constellation of Sagittarius, but the stars resemble a teapot shape. And in fact, the Milky Way resembles mist coming up out of the teapot. So just grab your binoculars and sort of explore. You're going to pick up some nice open clusters and some knots of nebulosity. And the Milky Way runs all the way up to the eastern sky. You can pick up the big 3 bright stars of the summer triangle and then follow the Milky Way through the middle of the triangle. And if you've got a dark sky location, see if you can see the dark band or the dark zone that cuts through the Milky Way. That's dark opaque dust in the galaxy that splits the Milky Way into more than one zone. So I'll leave it at that. I think that's a fair amount to see, and we're going to get some more dark sky coming up in the next little while. So I'll throw to questions now.
Hey, Chris, thanks for all that information. I had a question for you. I wondered if, I hope I didn't miss it and you already talked about this, but I wondered if you could go to the moon on July 31st, end of the month. Because I think there's a neat pattern that we can see there. And yeah, if you zoom into that a little bit, I think you can see that we've got, oh, not too much. Off to the left there is Jupiter. And then further to the left, of course, Saturn, as you pointed out before. And maybe if you advance a day or two, we see how the moon kind of walks through the whole grouping there. So that's going to be kind of a neat, I don't think that's officially a conjunction, but a neat grouping of the moon and Jupiter and Saturn all together. But on the 31st, they're in this nearly perfectly straight line.
Yeah. So yeah, you can, if you want to get a series of photos, take a photo opportunity and try to grab the moon on several nights, you can sort of catch its progress through. That's great. Yeah, thanks for pointing that one out.
There was a question from Peter. He asked if there are any lunar letter events.
Let's just see if I have any noted here. I think there may be in the period. Let's see. It's today. And
while Chris is searching for that, primarily we're talking about lunar X. It's an X-shaped pattern that appears around first quarter. It takes I think at least binoculars, a small telescope to just see the feature, right?
yeah. So the next one I have on my schedule, Blake, is August 25th, starting around 8 p.m.
Oh, so that's my talk. So we can't talk about that now.
You'll pick that up, yeah.
And lunar X is the big one. There are some other letter patterns, but they're not quite as obvious or prominent.
Yeah, we could point out this terrific NASA tool for those who are perhaps doing the Isabel Williams certificate or wanting to get more acquainted with the moon. If you go to this NASA website, which is the Moon Phase and Libration tool, it lets you actually dial in how the moon will look on any hour of any day. And so this is set to universal time. So this is now showing you the moon at 8 p.m. today's date. And if you click on the frame, it'll download a large format GIF or TIFF, I think it's a TIFF, which is annotated with major features labeled. And if you're doing it through a Newtonian telescope, you can scroll down here and do the south up version. and it'll have the labels the right way up, but the moon flipped around for your view through the eyepiece. And so that's this is a great tool. So what did we say? We said August 25th.
25.
That'll be the 26th at 0 UT. So 26 update, and there's the lunar X. You should be able to see it. I may have the hour a little off. Let's go 1 hour later. You can see it just coming in now. I'll go another hour. There you go. You can see the DX is right there. Hopefully everybody can see that in the video. And this is a great tool to show you how it will look and sort of practice.
And the lunar V is just above there, almost dead center.
Yeah, the lunar V is up here, and then there's also, let's see, there's a backwards E down there sometimes. Yeah, there's the V. There's an X. There's an L somewhere. I'll note it in my skylights when I get to it, but I have in the past highlighted the all the letters you can see.
Okay, thank you for that. When is Uranus reaching opposition? Is it around this time as well? Because is this a good time to try? This is sort of a challenge exercise to see if you can spot Uranus just with your eye, because it's right around the limit of magnitude limit of seeing things just with your eye.
So Uranus's opposition isn't until the 31st of October, and Neptune's is on September 11th. So
okay,
I know they seem like they're in the same patch of the sky, but because these closer planets are moving faster, they're not doing the same thing. So yeah, around the time Mars is doing its great show, then we can look at Neptune and Uranus as well.
Paul asked if the Great Red Spot is still shrinking. Have you heard anything new?
I haven't heard anybody mention it lately, but then we're just really getting into the time of year where it's going to be observed by a lot of people in the evening. So some of the people that may have not wanted to bother getting it in the middle of the night or in the morning are now going to be looking at it. Maybe they'll report, what they're seeing compared to last year. The other thing I didn't mention that's a bit unfortunate about these summertime oppositions is that the planets don't get very high in the sky. I mentioned that things look the best when they're highest. And you can see that even when Jupiter culminates or passes the meridian, the green line, around just before midnight in early August, it's really only 23 degrees above the horizon. So it's really not that high. And so we'll be looking through a lot of Earth's atmosphere at it. It'll be a fair bit of blurriness added because of that. But
and it looks like
what we get.
It looks like Stellarium is showing that they're just a titch below the ecliptic too. Yeah.
Yeah. The planets, of course, don't all fall exactly on the ecliptic. There's a number of degrees difference on them. That's right.
Okay, that's all for questions. Thank you.
We're back. Our next speaker, David Robitaille, is ready. He'll talk to us about imaging from his backyard. Go ahead, David.
Well, hello, everyone. My name is Dave Robitaille. A little bit of history about me. Pretty much, I grew up with a telescope in my hand. Some guys were cars. My other girlfriends were dolls. For me, it was a telescope. However, I've never really got into imaging until a few years ago, and it really re-energized my passion for this hobby. That with technology we have these days, that we can actually see things that professional astronomers 30 years ago would have only dreamt of, and now we can do that with modern and modest technology in our own backyards. It all started 2 years ago with the construction of my observatory in the backyard. I decided, that enough was enough to set up every night and back up every night, and I have to deal with the mosquitoes and being cold and freeze to death. So I said, no, the mistress, which is the telescope, as my wife calls it, will now have a house. Now what I love about it is the telescope is always set up polar line, ready to go. All I need to do is go and open the roof and turn on the switch and walk back inside the house and control everything from inside in my slippers with a nice cup of coffee and no bugs to deal with. One of the downside of the hobby, well, I think this picture was worth 1,000 words. You can really put in a lot of cash into this hobby, especially when you get into imaging, because obviously we always want to have the best equipment, the highest resolution, the best optics, the best mount. So you can spend a few dollars. Um, when I started a few years ago, I started with a very old dinosaur, as you can see here. That was a Meade LX200 that I picked up uh, in Barrie. And believe it or not, I actually used that telescope with an equatorial wedge and really started to learn and understand the basics of imaging. Um, and I'm actually proud that I have done that because I have learned with one of the most difficult instrument. I don't know many people that actually do imaging with an equatorial with the super wedge on a fork mount telescope like this. But this is how I learned, and because it was so difficult, I have now moved on to more modern equipment with an equatorial mount and modernized the optics as well. And my God, this was just a shock how easy it is to do now. And again, probably because I've learned the most difficult way to start. Uh, right now, I own a equatorial mount, a Skywatcher EQ6. The picture on the left here is a 8-inch RASA, it's the new optical systems that just came out. Um, it is very, very fast for imaging. The F ratio on this telescope is actually an F2, which I believe is like 10 times faster than the telescope on the right, which is a standard on the C8, you can see that the camera is attached to the back end of the telescope. And the best I can do with this is to reach a focal ratio of 6.3, where with the RASA telescope on the left, the camera is actually in front of the correcting plate. You don't see it now because of the two cap, but it's actually inside attached to the front. I can actually start seeing 17 magnitude galaxies with only a 30-second exposure. It is just fantastic how fast this instrument is. The camera that I use is a ZWO ASI 294MC Pro. This camera has the ability to cool to 35 degrees below ambient temperature. So, example, let's say that it is 0 degrees and on a very cold night, you could actually bring it down to minus 35 degrees. It's a little more difficult to cool the camera during the summer, but wintertime is pretty easy. And some people will ask, why do you want a camera to be cooled? Well, those sensors that you can see on the right picture, those kind of heat up very, very quickly when you're actually taking long exposures. They basically use a lot of power and it will create a lot of dark current and noise. And by keeping the chip at a much cooler temperature, it basically eliminates a lot of those artifacts, and it makes the image processing after much easier. A little joke here. Oh no, sorry, not now. I also use a guide scope. This one is a 60 millimeter that I have with a little black and white camera. And what the guide scope is, if I go back to a few slides back here, you can see the guide scope is actually mounted on each telescope here. And it's connected directly to the equatorial mount. And the main purpose of a guide scope, basically, it locks on a star, but you will always have some imperfections into the equatorial mount here, polar alignment that may not be perfect. And, unless you want to spend $30,000 on an equatorial mount, you will not have a perfectly built mount. So the purpose of this small telescope, the guide scope, it will lock on a star and it basically communicates with the mount, and it sees if the star is drifting a little bit to the left or to the right or up and down, and sends a signal to the mount. You got to go back down. You got to go to the left. You got to keep there. You can move there. Using a program called PHD, I believe it's actually stands for Push Dare Dummy or something like this. But it's quite efficient and it works great. This is a little common joke that I love between me and my wife. And the experience comes with time. When you get started in astronomy, in astro imaging, you will have success and a lot of failures. And then sometimes you just come up with a picture, and like the one you see of the Trifid Nebula on the left there, was one of my first greatest shot with my 10-inch LX200 of this nebula. And oh my God, was I ever proud of it. Look on the right, 1 year later, what experience can do. Now I look back and say, how could I have been proud of that? But this is all experience that you acquire. It's a lot of a learning curve, choosing the right optics, the right cameras, and I would say 70% of the job really is lying down in the processing of the image with either pics and sites that people are using. I personally still use Photoshop. I don't feel like to go out and learn a new software. I'm just starting to master Photoshop. But if you're putting the time and the effort and the hours, look at those two pictures, it speaks for itself, and it's only 1 year apart. And I'm still today performing better month after month. I can see the improvement. There's another picture here of the Andromeda Galaxy from 1 year ago. And this picture that I took, actually, no, sorry. First picture was taken 2 years ago, and the Andromeda Galaxy on the right was taken last summer at Starfest. And I can't wait right now for it to climb up a little bit better with my new RASC telescope. Start basically taking some more collecting some more photons out of this target. So perseverance is the most important thing. I've put up a little bit of a video here with some music. I do apologize for the music not lasting through the whole video because I have no idea what I'm doing with movie editing. It's a completely new experience for me. I tried to put this up together for this little tutorial here. So it will play some music, but then the music will stop. The pictures will keep scrolling down. So let's take a look at that. This is where the music stopped, but the pictures will carry on a little bit. This is the iris or the wide angle. And this is a zoom inside with an 8-inch telescope. This is the Eagle Nebula. Here we have the Dumbbell Nebula, planetary. Here's the Whale Galaxy. The Witch Broom. Trifid Nebula. One of my favorites so far, the North American Nebula. Whirlpool Galaxy. M81. Pinwheel. M82, the Exploding Galaxy. That is the Needle Galaxy. Sunflower, I really like this one. I think I did a good job on that one. And the Sombrero. I took this one actually last week. This is the Pelican Nebula with the RASC-TC. There's the Horsehead Nebula. The Crescent. Tiny little object, the Ring Nebula, the Fruit Loop, so we call it. The Tulip. And that is it. So 2 nights ago, I was actually very happy that the target was able to clear one of my neighbor's tree. And I was able to finally get the target that I wanted to put my hands on for a long time, which it's called the Dark Shark Nebula. It kind of looks like a shark or a dragon, if you will. Personally, I think it looks more like a dragon than a shark, but whichever way you prefer. So that is about it for me. Any questions, anyone?
Well, thank you. Very, very impressive, Dave. I wish we could have seen your images a little longer.
Yeah, I know. It's like I said, it's really, I'm very inexperienced with video editing. I'm sure there is a way to slow down how the pictures are going. Again, I need more time to learn those softwares. It's just kind of complicated to learn that from A to Z, but I'm sure I'll get there at some point.
Very good. So let's go to questions. Blake, anything online?
We have a couple of questions. One for me, Dave. What's your sky like? Your backyard like? Do you have to deal with much light pollution and so on?
I am actually very, very fortunate. Unfortunately, I have to deal more trees than street lights. I live about 25 minutes north of Mary, in a little town called Coldwater. The sky level up here is, I would say, 4.5, which is very, very decent. I can see the Milky Way splitting in those 2 parts. The zenith, no problem. I can pick up M31 naked eye. Actually, a few nights ago, while I was imaging the Shark Nebula, I could actually even have a glimpse of the North American naked eye, which doesn't happen all the time. Depends how clear the skies here or the transparency is. But yeah, I'm in a village. I have streets around me, but there's nowhere like you guys down in Toronto where you can really, the only thing you can see is almost the moon. Here, I'm very, very happy to have the sky I have.
I remember those skies when I visited Jeff Garrity. Yeah.
Yes, I'm actually, Jeff was living just a couple of lines away from me here. Yeah.
Okay.
Missed the guy.
Yeah, we all do. Magnolia asked, what have you found to be the most challenging part getting into astro imaging?
A couple of things that are difficult is, first, if you have to really understand the astromechanics of what's going on with the sky and how it moves, to be able to, you have to take a picture of something that is constantly in motion, and you have to have your camera aim at this thing for hours on to collect data to come up with a picture. That is one thing. So that's why you need those little guide scope and so on, and then you have to fight the environment, the dew, and clouds. Sometimes you can have a cloud that will pass by while you're watching the hockey game downstairs, and it just throws off your lighting. And so you have to pay attention to these things. And I think the most challenging part of doing imaging for me was to learn how to process those images. And I think everybody that tries to do that at one point or another is we all want to overdo it, and you basically are killing the data instead of helping it. So if anyone wants to get into imaging when it comes to processing either with PixInsight or with Photoshop, just do it baby steps at a time. When it comes to stretching and doing the levels, always just baby steps and compare and so on. And save your picture as soon as you're happy, save it. Because you can work on an image. It happened to me several times. You can work on an image for 3 hours and then you go, oh my God, I almost have it and it's almost perfect. And then you do that little tiny little mistake and you just destroy it completely. And then you just work 3-4 hours with absolutely nothing. You get start from scratch. So keep saving your work as you go and as you process. So yeah, processing I think is the most challenging thing.
Okay, very good. I have a question for you, given that you
Yes.
have so many fantastic images and you've shown us them pretty quickly. Do you have an online gallery? Do you put your photos in?
I do not at this point yet. However, I do share a lot of my pictures on the Facebook, Starfest Facebook. Paul is aware of that. I do share a lot of my pictures there. Quite a few of us do that there. So yeah, more than welcome to look for Starfest Facebook page, and you'll see my work there.
All right, good. Paul asked some details about the camera, and I was curious too. Is it a one-shot color or is it a monochrome?
No, it is a one-shot color. This is a big a decision you have to make when you want to do imaging. Am I going to go with a mono, which is black and white, or a one-shot color? You definitely can pick up quite a little bit more detail with a mono camera because they're more sensitive. But for example, now with the RASA, you saw this picture of the Shark Nebula that I worked on a couple of nights ago. If I go back here, there we go. This, believe it or not, was only like 20 pictures of 2 minutes exposure stacked together. And that's how quick this telescope can pick it up. And it's in color like that when you process. Where with the mono camera, you need to actually take, let's say, 20 pictures with the blue filter and 20 pictures with the red filter and 20 pictures with the green one. And then you need to combine all of that. So it's a lot more work into the post processing. But there is different things you can do with mono cameras. Like I believe the Hubble pellets, like the telescope pictures can only be done with those mono cameras and not with a one-shot color. But these days, the one-shot color have really come a long way. And here's the results right there with this target, which you cannot see that at all with the naked eye. You really need some exposure, and the colors are very contrasty, as you can see. The yellow and orange stars and the blue ones are very distinct.
Yeah, looks really good, and it does make the processing a lot easier, I imagine.
Well, it's much shorter. You know, you're gonna spend probably only one. Basically, with mono camera, because of all the filters, I think it's 3 times more work than with the color camera. But can you get better results with the mono? I don't disagree. I would think you can get better resolution and so on, and they are more sensitive. That's for sure.
Bernard asked a question. He asked if the ASI 294 would be a good camera. He's thinking about getting one for a long focal length scope.
My answer to that would be yes, depending what kind of long focal length are we talking about. Let's say a Schmidt Cassegrain or a long focal refractor. Because
he didn't
that could make a difference. There is a website called, I believe, Astronomy Tools, if I'm not mistaken, where you can actually plug in the type of telescope that you have or that you may want to buy, and then put in the type of camera that you have or may want to buy, and it will tell you exactly where, if it's good for that type of telescope. Right now, for my C8 and especially for the RASA, the 294 is one of the best camera there is to be with that telescope. Other cameras will have the pixels too big or too small. You know, it's, you have to have the right balance. So yes, that's actually a very good question. But I don't know, Paul, am I saying the right place here? Astronomy Tools, I believe that's what the website is called, when you can actually go and find these things out.
Dave, do you want to check that? We don't need to know right away, but maybe we can update everybody after, and we can attach it to the uploaded video. So
Absolutely.
if you could find that out, that'd be great. I think I've seen that website, but I don't remember the address off the top of my head.
Yeah, it's fantastic because it will tell you if with this camera and this telescope, if you will be undersampling or oversampling, and under what conditions. Sometimes it will be a perfect match, but it will be a perfect match for good seeing conditions. Well, when do we up here in Canada see good seeing conditions?
Right.
Maybe 1 out of 20 nights, if that. So, you know, it tells you absolutely everything that you need to know. Which camera will be best at a moderate seeing or poor seeing and so on. It's just a great tool for you. So yes, I will find out and send you the link.
Okay, thanks.
You're welcome.
The camera is obviously cool, the one that you use, so that gets rid of a lot of noise. But do you still do some of the other things like take darks and flats?
Oh yes, yes. You need to basically, depending on what telescope you're using, there is those darks, there's those flats. I have noticed with the Schmidt-Cassegrains, the SCTs with the long focal lengths at 6.3 or so on, I need to take some flats, which basically is that a light picture with nothing on. Kind of tricky to take, but once you have it, you have it in the library. Because sometimes you will have dust on your sensors and it will look like little donuts, and those flats will help removing this. The picture you see right now on screen of the Shark Nebula, there's no flats at all. I've noticed with the RASA, I have no idea if it's because it's an F2, and I've been using it for a month now, and doesn't matter how hard I process and over exaggerate the images, I have not seen a donut or a speck of dust yet. Is it because it doesn't focus on it? I have no idea, but this is something I just learned for myself, and I actually would like to talk about this on some forums. If other people using the RASA scopes at F2 are actually experiencing the same thing as well. There's no more buzz bunnies since I use that telescope, and if I put my camera on the C8, poof, they're back. But you can remove those with flats. There's also darks, because a camera like this will also create what we call amp glow. So the longer your exposure are, it's going to be like glowing rays on the side of your image. And when you take darks, which basically a dark, if you take a 2-minute exposure for your light, you put your cap on and you take a 2-minute exposure at the same temperature. That's very, very important. Same temperature of your lights. And then you combine, for example, that picture here, I had 20 lights, I had 20 darks, and I also took 20 biases. Biases is the fastest exposure with the cap on that your camera can take, which is not 100 of a second. And this actually helps removing as well the hot and cold pixels out of your image. So when you combine all of those lights, darks, flats, and so on, and biases, it's called calibrating. So you usually a software called Deep Sky Stacker for doing that. It's actually free online. So you just put all your pictures in there and you click the button and it comes up with one final image that almost look black and white with only 2 or 3 pictures, and then you go, oh my God, what happened? You know, I spent 4 hours taking a picture of this and it's gone. It's only 3 stars. Don't panic. you can take that picture and you bring it to a processing software like Photoshop or PixInsight, and you start extracting the data, and voila, it just starts coming out and coming out and coming out. And you just try to keep doing this until, to keep it without having too much of the noise coming out. That's the enemy number one of an astro imager is the noise. Because if there is noise and the more you try to process for example, the shark would be way much more apparent, but then you're going to see all kinds of noise in there, and it doesn't look good. It looks too grainy and so on. So yeah, lots of tools. There's also some plugins that you can download for a very modest price to add on to Photoshop that are actually just created especially for imaging. And all you have to do is click on the one button. It will basically do in 1 minute what it would take you to do with Photoshop manually over an hour and a half. It's very, very sweet, those little tools. I don't remember the name. I think it's Carbonist tools, if I'm not. So basically, they are astronomy tools, especially designed for Photoshop, and you just add it to Photoshop.
All right, thanks for all those answers.
You're welcome.
That's it for our questions.
Take care. Thank you for having me, guys.
All right, and we're back with our next speaker, Artash Nath, and he'll talk to us about seismic vibrations from outer space to subsurface. Take it away, Artash.
Great, thank you. Hi, everyone. Good evening. My name's Artash, and I'm a grade 8 student going to grade 9. And today I'm going to be talking to you about one of my latest projects on observations. It's called From Outer Space to Subsurface: Seismic Vibrations, How to Measure Them, and the Impact of the COVID-19 Lockdown. Let's get started. All right, first of all, how are seismic vibrations useful? Well, measuring seismic vibrations has many usefuls. First, it can help us understand more about the geology of a planet, such as the interior structure of the planet, the tectonic movements, or volcanoes. Second, it can tell us about weather patterns on a planet, such as dust storms or waves. It can even tell us about meteor strikes, because when meteors collide with the surface of the Earth, they cause seismic vibrations. And finally, seismic vibrations can tell us about the level of human activity, such as the level of transport or traffic on the roads. So seismic vibrations are definitely very useful. But how can we measure seismic vibrations? For that, we use a seismometer. And how does a seismometer work? Well, it's in fact very simple, and it's completely based off pendulums. Let me show you an example. So as you can see, I have a pendulum here, and the pendulum is attached with a pencil. And let's pretend that I am the Earth. All right, so now when the Earth starts moving, the pendulum will also start moving. And if I have a piece of paper, so when I move, the heavy mass on the pendulum will also slowly start moving. And the pencil will start moving on the paper. And if we start rolling this paper, we'll be able to get the level of seismic vibration over time, just using a pendulum. A seismometer works on 3 of these pendulums: 2 sideways pendulums and 1 vertical pendulum to measure the seismic vibration in all 3 axes. In fact, if we want to get more sensitive seismometers, we use something called an inverted seismometer, where we have like an inverted pendulum, so the pendulum is upside down. This means that it's even more sensitive to seismic vibrations and will move very easily. Now, funnily, astronomy and seismic vibrations share a very unique relationship, because on one hand, we spend millions of dollars trying to create seismometers to measure seismic vibrations to understand planetary geology. But on the other hand, we also spend millions of dollars trying to create instruments to isolate or remove these seismic vibrations from other instruments. So an example of this would be the LIGO, To detect gravitational waves using the LIGO, we need to isolate human-made vibrations. If you would like to know a little bit more about the LIGO experiment, you can just, I've in fact given a talk on it, so you can check that out. And there's something very ironic about it because you use a pendulum both to measure seismic vibrations, as I described in the earlier slide, but you also use pendulums to isolate seismic vibrations. So this is something pretty funny. And all right, so let's move from the Earth to the Moon. As you know, the Apollo missions, except for Apollo 17, carried seismometers to the Moon. Unfortunately, the Apollo 11 seismometer broke down after a couple of weeks, but fortunately, all the other seismometers lasted until 1977. And this formed a nice kind of network of seismometers on the surface of the Moon. So we could measure seismic vibrations on the surface of the Moon, but what causes moonquakes? Because we know that the Moon doesn't have active tectonic plates on the Earth. So how do vibrations form on the surface of the Moon? Well, it can be caused by two things. First of all, by tidal forces. Because the Moon causes tides on the water or the oceans of Earth. And the other way around is also there, except that the Moon doesn't have any water for us to make tides on. So instead, the gravitational pull of the Earth makes creases on the surface of the Moon, which can cause seismic vibrations. The second way to have moonquakes on the on the Moon is through global contraction. Because the core of the Moon is still slowly cooling down a bit and shrinking, which causes the surface to slowly shrivel up, leading to moonquakes. So this network of seismometers that were placed on the Moon detected several events. First of all, they were in fact able to detect one meteor strike on the surface of the Moon every single day, which is because the Moon obviously does not have an atmosphere. In addition to this, it was able to detect 28 shallow moonquakes, which peaked at a magnitude earthquake of 5. And one thing really amazing about the seismometer network on the Moon is that they even measured man-made seismic vibrations. How is this? Well, when the astronauts left the Moon, they didn't need the ascent module anymore. So they decided to purposefully crash the ascent module onto the surface of the Moon. And since they knew exactly where it was going to land and how much this ascent module weighs, they would be able to actually calibrate the seismometer network to make it more accurate. All right, enough about the Moon. Let's talk about Mars, the red planet. The first seismometers that were placed on Mars were in the Viking landers, Viking 1 and Viking 2. Now, they both had seismometers, but unfortunately, Viking 1 seismometer did not activate, but Viking 2 seismometer did. But the problem was that, as you can see in the picture, the seismometer was placed on top of the rover, the lander's bay, which meant it was also prone to vibrations caused by the wind, for example, or by the internal machinery of the rover, instead of being only affected by seismic vibrations. So this meant that it was not very accurate in actually measuring seismic vibrations. Like, for example, in this graph here, the top line you can see in the graph is the wind speed, and the bottom is the seismic vibrations. And you can see a really strong relation between the two. So it was not really able to detect any significant seismic vibrations. All right, let's move a bit closer to the present. In 2018, when NASA landed the Mars InSight on Mars. Mars InSight, in fact, does have a seismometer, but they were much better prepared. In the picture, you can see a white dome, which is the seismometer cover. And under this white dome are two seismometers, each of them fully functioning. The first seismometer is the main seismometer, and this is the more sensitive seismometer. But under the white dome, there's also a second seismometer as a kind of redundancy seismometer in case the first one failed, as NASA always has redundancies. And by the way, the white dome on top of the seismometers isolated them from vibrations caused by the wind. to make it more sensitive. And I'm gonna show you a small video that's you can hear the sonification of the seismic vibrations for different events that this seismometer measured on the surface of the Mars. So first is the wind. It's very faint, but you can still hear it. All right, the next sound you're gonna hear is from the Mars quake. And this comes up a little bit louder. Finally, the last one is the sonification of the vibrations caused by the robotic arm on Mars InSight. So as you heard, these seismic events are, so the earthquake was you were very much able to differentiate the earthquake from other stuff, as for example, the robotic arm movement. All right, so what causes seismic vibrations or Mars quakes on Mars? Well, it doesn't share a tidal force with the Earth, but as once the Mars had an active core, it's still cooling down, which causes global contraction, which means that the core is still cooling down, which again, just like in the moon, causes shrivels on the moon surface, leading to Mars quakes. The Mars InSight seismometer was able to detect several Mars seismic events. First, it was able to detect 24 Mars quakes that propagated from deep inside Mars's core. So these are much more deeper formed Mars quakes, and they tend to have a lower frequency measured. It was in addition able to detect 150 smaller surface types Mars quakes, which tend to have a slightly higher frequency. Now, let's compare quakes between Earth, Mars, and Moon. All right, so earthquakes on Earth tend to have a much higher magnitude. For example, an example of an earthquake on Earth could have a magnitude up to 9 or even 8 or 9. But on the other hand, on Moon or Mars, you don't really get quakes that are higher than 4 or 5, which means that quakes on Mars and Moon can be thousands of times less strong than the ones on Earth, as the earthquake magnitude scale is logarithmic. But even though quakes on Mars and Moon are much less high in magnitude, they're also much longer. So as you can see here, in the two graphs for the Mars quake and Moon quake, they last to around 2,000 or 1,500 seconds, which comes up to like 30 or to 45 minutes of an earthquake. Whereas on Earth, you only get quakes that are around 20 to 20 seconds, which is much shorter. This is because that on the Earth, we have the ocean, and the ocean actually dampens these seismic vibrations. In addition, on the Earth, the mantle or the crust of the Earth is mostly connected, which means that the vibrations dampen quickly. But on the Moon or on Mars, there's no water to dampen the seismic vibrations from these quakes. So, and also, the crust is divided into many pieces, which means that the seismic vibration lasts for much longer. All right, so enough about Moon and Mars. Let's go back to Earth, because I wanted to find out a bit more about man-made vibrations. So, all right, so there are a couple different examples of seismic vibrations on the Earth that are human-made. For example, there's the train signals. So if you see a train passing on top of a bridge, then it'll cause a very high amount of vibration, and it'll also be for a pretty long time. But in a cruise ship, on the other hand, it slowly becomes around medium high in seismic vibrations and then slowly phases out. or in a mining or explosion that happens, it's going to be very short and a very high burst of energy. So now let's talk about earthquakes. Earthquakes are very large seismic events, so they can be measured in several seismic locations, as you can see in the graph below. So these signals can be received by seismic monitor stations and can be processed to find out more about the earthquakes. Now, I wanted to finally do an experiment to see how the seismic vibrations change during the COVID-19 lockdown in Canada. So I picked 6 cities and downloaded seismic data over time for each of these cities. I processed this data using Python. And in fact, this data comes at 100 lines per second, which is way too much because we don't want to focus on each fluctuation. We want to look at the whole trend of seismic vibrations. So I kept averaging the seismic vibration data until I got a kind of trend you can see on the right. And I calculated this trend for all of the 6 cities. So as an example, in Calgary, you can see a pretty significant decrease in seismic vibrations, around 30%. In Edmonton, slightly less, but it's still there. In Montreal, you can also see a dip in seismic vibrations. In Ottawa, it's slightly different. I measured an 8% increase in seismic vibrations during the lockdown. In Yellowknife, there was the most decrease at almost half the seismic vibrations. And finally, home in Toronto, there was also a decrease. So as you guys saw, there was a decrease in seismic vibrations in almost every single of the cities I measured during the COVID-19 lockdown restriction. All right, so the data that that you can get for seismic vibrations, there's in fact a large network of people with seismometers around the globe, and this data is completely open source, and anyone can get and install a mini seismometer called a Raspberry Shake. And I recently got a Raspberry Shake, and I'm going to be giving you, in fact, a demo of my Raspberry Shake at work. All right, so here in this moving graph, here I hope you can see it, this is the live seismic data from a Raspberry Shake in another room. Now, it looks pretty uniform, but now I'm going to ask my sister in the other room to jump near the seismometer. Watch what happens. All right, so at the end of this graph, you can see there's a significant bump when my sister jumped near the seismometer. So it's pretty sensitive, and you can get data in real time from this website for any of the stations. So that's pretty cool. And in case you were interested in my experiment about measuring the lockdown, measuring the seismic vibrations in the lockdown, I've created a tutorial that anyone can do it, and it walks you through all the steps of calculating the change in seismic vibrations during the lockdown for your cities. It's available at my GitHub. My GitHub username is Artash Nath. And if you would like to start learning more about seismic vibrations, feel free to join the Software Underground community, which is a place for scientists that like seismic vibrations, rocks, and computers. Thank you very much for listening. And if you have any questions, I would be more than happy to answer them.
Fabulous, Artash. Thank you so much. Very neat, very interesting. Always a learning experience. All right, so let's go to Blake with questions, if any.
Hi, Artash. I have a question for you, and I think you've kind of answered it or clarified it already. I thought that the Mars InSight lander, that the device that's supposed to drill into the ground was part of the system to do seismic work, but I guess it's not. So the seismometers are under that white dome, is that right?
That is right, but I'm glad that you brought that point up because they are linked in a way, actually. Because when the mole instrument, which is an instrument that's going to try to drill down into Mars' surface, is drilling, it's going to cause even more seismic vibration, because obviously if you keep banging the surface of Mars, it's going to cause some seismic vibrations. And obviously those vibrations are going to be picked up by the seismometer. So what the experiment that's going to be going on is that when the mole is drilling, they're going to see what changes are observed in the seismometer. So this shows what is the transfer of vibration through the surface of Mars caused by the mole. So that's also pretty interesting additional experiment that can be made.
Now the mole appears to be stuck. I've been wondering if there's a big rock under the ground and they can't get past it. Do you know if there are plans to maybe move it to a different location or something like that?
In fact, I think they've solved that problem, because Mars Insight also has a robotic arm, and they've been using that robotic arm to in fact help the mole or readjust the mole to help it dig more efficiently and make it dig using the robotic arm.
Okay. Astro YYZ asks, what accounts for Mars quakes? On Earth, we have plate tectonics and lava and things like that. So can you explain that, please?
Sure. Well, obviously, Mars doesn't have an active core anymore, but its core is right now cooling down, because it was once super hot, and now it's starting to cool down. And it's not completely cooled down yet. And as it cools down even more, it shrinks. And this shrinkage is kind of like you're shriveling up a raisin, right? So as it kind of shrivels up the surface of Mars, we're observing creases in the Mars surface, which in turn causes Mars quakes.
Okay, thank you. And I have another question for you. Do you have a theory at this stage as to why there's, in most cities, a decrease in seismic activity over the last little while during the COVID lockdown? Do you have any ideas why this might be happening?
Yeah, for sure. Because these seismic monitors are placed near cities. For example, the seismic monitor by IRIS in Toronto is right near Leslie Spit, which is near the harborfront. And these seismic monitors will obviously be recording some of the man-made vibrations. And during the COVID-19 lockdown restrictions, people started to go out much less, right? Only maybe a couple of times a week, and only for essential reasons, because most of us are staying at home and trying to social distance. So obviously the traffic in the streets will be considerably less. So we will observe a decrease in seismic vibrations. And in fact, this also goes to show how of an indicator these seismic vibrations can be on the traffic, the human traffic in cities.
Okay, thanks a lot. That's it for our questions.
Thank you.
Oh, wait. I got one more, I think. Yeah, yes. Paul asks, he has a vibration app on his phone. Does the Raspberry Pi work in the same sort of way?
Good question. Well, the seismic kind of vibration monitor inside your phone would most likely work through an accelerometer. So when you vibrate, the accelerometer is moving up and down. So you can kind of measure the seismic vibrations that way. But the Raspberry Pi Shake is a little bit slightly kind of a bigger instrument. So it has two parts, a Raspberry Pi and a seismic monitor sensor. So this is a bit different. So inside this kind of seismic module, there is a kind of tube. And as I talked about pendulums earlier inside my presentation, it works on a similar mechanism as that. So a more kind of physical mechanism. Like if you have a spring inside it and a weight, when you shake it, it's moving up and down, which can then be measured. So it's more of a physical method compared to the phone.
All right, very good. One last question. Do you want to be an astronaut?
I would definitely like to pursue a career related to space exploration and artificial intelligence. I'm not completely sure of what I would like to do, but I would definitely want to follow in those topics.
All right. Awesome. Thanks a lot.
Thanks.
All right, thanks again, Artash. Great presentation. So give us a minute or so and we'll get our next speaker all set up. We'll be right back. All right, we're back with announcements. Here is our president, Ralph Chou. Go ahead, Ralph.
Okay, thank you, Paul. Well, it's unfortunate we weren't able to hear Frank tonight, but bandwidth problems have really interfered with his presentation, but hopefully next time around we'll be able to hear from him. Anyway, let's take a look at what's going on over the next little while in the Toronto Centre. Our next online gathering will be our Recreational Astronomy night online on Wednesday, the 19th of August at 7:30 p.m. So far, we have confirmed Blake Nancrow doing the sky this month. And as of this morning, at least, we still had 2 open slots for the program. So if anybody's interested in doing a presentation, please contact Paul and let him know, and he'll be happy to slot you in, and then we'll put you into the website announcement as well. So again, that'll be on 19th of August at 7:30 p.m. We will be returning to our speakers nights online in September, and we have confirmed that our speaker on the 30th of September will be Alyssa Obertus, who is the PhD candidate at the Department of Astronomy and Astrophysics at the University of Toronto. She'll be speaking on exoplanets. We haven't got an exact title yet, but we should have that hopefully by the August online session. Okay, as you know, we suspended education and public outreach when the government put us into lockdown, and all EPO activities remain suspended until further notice. We'll see what happens as the province goes into stage 3, whether that'll allow us to resume some of those activities. But we do have some work to do to coordinate that with the various authorities, and we'll let you know as soon as we have an idea of when we can go ahead with that. Similarly, our access to the Science Center for face-to-face meetings is still suspended. So until the Science Center reopens, we'll be relying on online gatherings as well. The same problem exists for observing. So all of our programs with the public libraries, as well as any observing programs that we've been holding at, for example, Bayview Village Park or at Long Sault Conservation Area, cannot proceed until we have clearance to get back in front of people. And the problem is going to be, how do you share eyepieces and things like that? So again, EPO committee is working on that, and we hope to have a solution in the not too distant future. In the meantime, many of you are aware that the RASC National Office has organized a number of online programs, including an online speaker series. And I certainly would recommend that you go to rasc.ca to take a look at what they're offering there. The speaker series is particularly interesting, but there's a lot of other things online as well. I would also like to point out that there are a number of presentations that members of Toronto Centre, including myself, made at the Halifax General Assembly back in 2015 that have just been made available online at the Halifax Centre's website. And you can have a look at those. Some of those presentations are quite interesting. The Carr Astronomical Observatory was closed down when the pandemic triggered the state of emergency, but I'm happy to announce that we are working towards reopening of the CAO on a very restricted basis. We had a meeting last night of the CAO Management Committee to review all the paperwork that we've had to prepare in advance for the reopening. We're waiting for just a couple of things to be cleared by legal review. And once that's done, we will be talking with some of the other authorities that might be affected by our operations. And I hope to be able to put out an announcement about CAO operations in the not too distant future. It is going to be a very different way in which we operate the observatory going forward because of the social distancing requirements and also the need to clean and disinfect the facilities during and after each use. And that's what's really been capturing the attention of the CAO committee over the last couple of weeks. But again, we are getting closer to a time that I think we'll be able to re-access the property and start our operations there again. So again, stand by for that. I guess that's it for now. Thank you all for tuning into our broadcast tonight. It's now approximately 9:24, which means that we have enough time to get away and maybe step outside and have a look at Comet Neowise before it sets in the evening sky. And so I will wish you a safe time for the next few weeks and clear skies, and we'll see you online on August 19th. Good night, everybody. Stay safe.